y is equal to k is a tangent at the maximum point on the curve y is equal to x cubed plus 4x squared minus 16x minus 48. Find the coordinates of the point where the tangent touches the curve, hence state the value of k. Find the coordinate of the other point where the tangent crosses the curve, and find the area of the shaded region. Right, so we've got to find the coordinates of this point here where the tangent touches this curve. Now, in order to find the equation of tangent, we need to know the value of the gradient, where the coordinates where the gradient of this is equal to 0. So if we write down the equation of the curve, which is y is equal to x cubed plus 4x squared minus 16x minus 48, if we now differentiate, that becomes 3x squared plus 8x minus 16, and you get nothing from the minus 48. For a maximum, or turning point, what we got here, dy by dx is equal to 0. So we need to solve 3x squared plus 8x minus 16 is equal to 0. So solving that, 3 times minus 16 is the product, which is minus 48, and the middle term, which we call the sum, is 8. We want two numbers, when we multiply them together, we get minus 48, and we add the same two numbers, we get 8. So the answer will be minus 4, 12. Minus 4 times 12 gives minus 48. Minus 4 plus 12 is equal to 8. So writing down the quadratic but splitting the middle term up to minus 4x plus 12x, we've still got the minus 16, and then factorised by what's known as grouping. So we group these two terms together, so we're just going to have x coming out as a common factor. That will give me 3x minus 4. Bring down the sign here, which is plus. Common factor here of 4, take that out. And again, we're going to get 3x squared minus 4 is equal to 0. So we got the same thing here, so we know we've done it correctly. So now we have a common factor of 3x minus 4, so we take that out, and we're left with x plus 4 is equal to 0. So x is equal to 4 over 3. Now 4 over 3 is here, so that would be actually the other point here, the minimum point. And x is equal to minus 4 is over here, is the maximum point which we actually want. We need to find the y coordinate, so at x is equal to minus 4, we substitute back into y. So y will be minus 4 cubed plus 4 times minus 4 squared minus 16 times minus 4 minus 48, and that will give me 16. So the coordinate of this particular point here is going to be minus 4, 16, and this is the line y is equal to k. Therefore, k will be equal to 16, and we have the line y is equal to 16. B, we now need to find the coordinates of this point here. We know the y coordinate is 16, so we'll take our function and put it equal to 16. So we need to solve x cubed plus 4x squared minus 16x minus 48 is equal to 16. Now, in an exam, you can use your calculator solver, but going back to solving it algebraically, so if we put it equal to 0, so we get x cubed plus 4x squared minus 16x, bring the 16 over, that becomes minus 64 is equal to 0. We know that x plus 4 is a factor from the fact that this here is a solution to it here as well. So x plus 4 is a factor. So using polynomial division, we can find the other factors. So we've got x plus 4 into x cubed plus 4x squared minus 16x minus 64. So x cubed divided by x gives me x squared times x gives me x cubed, x squared times 4 gives me 4x. We get nothing when we do the subtraction, so we need to bring down the next two terms, which are minus 16x minus 64. And there we do minus 16x divided by x, which gives me minus 16. Put everything in the right column. And then multiplying, we get minus 16x minus 64. We get no remainder. And we expected that because we knew that x plus 4 was a factor. So, this will now become as x plus 4 times x squared minus 16. We recognise this as the difference of two squares, so this now becomes x plus 4 x plus 4, x minus 4 is equal to 0. We've got a repeated root here, which refers to this one here. So here we know the point now to be x is equal to 4, and the coordinates of this point are going to be 4, 16, because we know the y coordinate was 16. Right, we're now in a position to do part C, which is to find the area. So the area, we will need to integrate the curve from minus 4 to 4 of this one, which is on the top, 16, minus this one. It doesn't matter if this is below the axis or not. So, because we're doing the area between two curves, so we want the integral from minus 4, starting point, to the end point, which is 4, of 16, minus, and we need to make sure we put this into brackets, x squared plus 4x squared minus 16 minus 48 dx. Removing the bracket, that's going to give me 16 minus x cubed minus 4x plus 16x plus 48. Be very careful with the minus sign because it's minus it. Then we can do the 16 plus 48 makes 64. So we need to do the integral from minus 4 to 4, 64 minus x cubed minus 4x squared plus 16x dx. We're now set up the integral. We're ready to integrate. So integrating this becomes 64x minus x to the 4 over 4 minus 4x cubed over 3 plus 16x squared over 2, which is 8x squared. Now the limits go now here from minus 4 to 4. We now substitute the higher limit in. So 64 times 4 minus 4 to the 4 divided by 4 minus 4 thirds times 4 cubed plus 8 times 4 squared minus, put it into brackets, 64 times minus 4 minus 4 to the power of 4 divided by 4 minus 4 over 3 times minus 4 cubed plus 8 times minus 4 squared. So working each of these out, 64 times 4 is 256. 4 to the 4 divided by 4 gives me minus 64. This now gives me minus 4 times 4 cubed, which is 256 over 3. And then 8 times 4 squared is 128. Now being very careful here, 64 times minus 4 is negative, but minus it will make it a plus 256. Minus 4 to the 4 is positive, times a negative negative will make that plus 64. Minus 4 cubed is a negative, times a negative makes it positive, but times another negative will make that negative. So minus 256 over 3. And then 8 times minus 4 squared is positive, and that negative there will make it a negative. So we can do a bit of cancelling. The minus 64 and the 64 will cancel, and the 128 and the minus 128 will cancel, and then we can work out 2 times 256 plus minus 2 times 256 over 3, which will give me 1024 over 3, which is the correct answer for this area. Okay, so this has been a video to show you how to find the area between two curves where one of the lines is a horizontal tangent. I hope you've understood, and I thank you very much for watching.